So we are back. So as usual, include stdio.h. Then as usual, our int main. Then our curly brackets. All right. So as usual, we always need our return 0. Then I made mention about how array works. So this is the format for declaring an array. So we'll start with the data type of that array, then the name of the array and the array size. So for this example, I'm using arrays of 8. Okay, so the int, I'm using integer data type because everything here must be integer. Okay, arrays take only a single data type. So if you want to use integer, you are going to use integer all true. If you want to use character, you use character all true. If you want to use float, you use float all true. All right. So now we're working with integer, so I use the data type as int here. Then I choose to name it as array int, all right, array underscore int. Then this 8 is the number of elements you have. So each of them are called elements. Each of the values here are elements. So if you count each of them, we have 1, 2, 3, 4, 5, 6, 7, 8. So they're actually 8 in number. So that's the number you're going to put inside this bracket, which is this array size here. All right. But then in the real sense in programming, our counting usually starts from 0. That means this first one is 0. All right. So that is 0, 1, 2, 3, down to 7. All right. So just ignore the 8 aspect. The 8 is just like there's something called the null part of array, which we are going to see later on. So you get to understand why probably the number is like a bit increased. But in the real sense, it is 7. So even if I, for example, if I put 10 here, that means it will be like, it will count here as 10. That means I'm going to increase this one to like maybe extra 2. But in the real sense, it will stop at 9 in this place. So it will be array int 8. What's it? It does the 20, which is this other one, this 20 here. Then we have the last one, which will be array 9. Okay, so array int 9. So that's 22. All right, so that was what I was trying to do here. So let me just highlight, let me copy this stuff. So I just want us to test what we are doing this place. So if I paste this here, so the issue then was that it seems to have to always declare it alongside it. So if you want to declare your arrays, just put it, declare it and list it directly like this. Okay, so don't put it like separate up here or whatever. All right, so what I want to do now, I want us to really test each of the values if this place is indeed 0 or this place is indeed 9 or 10. Okay, so we're going to use printf as usual %d. This one deal with integer. Okay, so %d comma, then I'm going to call the array and specify on which position I want to print out. So if I say array 0, that means I'm expecting to print out this 10 for me. So let's try this. So if I print this out, what's the message? Expected or before semi printf. Is there an issue here? 0. Yeah, this is common now. Printf %d new line. There's semicolon here. Let me print this again. Okay, so that's the 10 here now. So that means indeed this first one counts from 0. So let's try the last one, which is 9. So which is this 22 part. So let's see if it will give us that 22. So it gives us 22. Yeah. Let's try this 10, which I'm not expecting to give me anything. I say actually give me something. Sorry, actually give me something unusual. So it's just a random stuff. Or no, it shouldn't give me anything. It should have given me an error message. You understand? So we don't count that last number. Always it will end with 9. Okay, that's 0, 1, 2, 3, 4, 5, 7, 8, 9. But in the real sense of counting it normally, it will count as 10. Right. So this is just how to arrange arrays and just learn how to change each of them. So for example, if I want to change this 10 that is in this 0 part, so what I will just do, I'll just call the name of the array again. Then I will specify that it's position 0. Then I can change the value to whatever I want. So probably I can change this one to 30. So if I change this array in 0 position, that means this 10 will change to 30. So now let's check if it will indeed update. So that's position 0. So if I print this out, you can see it has changed to 30. So that's just how to also modify an array. All right. So now let's proceed. Now I want to write an array list using for loop. Okay. So now how to write an array list? Let's, for example, probably if I want to write something like 1, 2, 3, 4. So doing it one by one, yeah, may seem kind of tedious a bit. Like maybe doing this like this. So that sometimes you may need to use for loop to just put in some arrays. It might not even be numbers, can even just be some characters also. So instead of doing these kind of steps, let me show you how to do that using for loop. Okay, so we're going to say we're going to well, since we're dealing with for loop first, in short, let's first declare the normal lists or the arrays. So you can choose to name it any, you can just name it R as the name of the array. So I think it's only when it comes to something like this, you can choose to declare it this way. That is when you don't want to physically your own, you don't want to your own self put those values. You understand? So don't make the difference. So if I'm to put this stuff like this, I can do it this way. If I'm not putting it directly like this, then I'm allowed to declare it in this format. That means it means that probably I would like to use for loop. Okay, so if I'm to use for loop, as usual, for loops come with an initialization, the condition, and the iteration. So initialization, we're going to start counting from 0 as expected. Okay, so I'm going to start counting from 0. Then the condition is the next part. So condition, I want it to be, since this is 10, that means since it's 10, that means the numbers you are going to take are 9 in your mind. Okay, remember this 10 is just the number of elements, but in the real sense of coding, it is 9. That is 0 to 9. All right, not 1 to 9. So 0 to 9 just as if it's like 1 to 10 kind of. Okay, so we are dealing with condition here. So the condition part here would then be I. Remember this I first one, the initialization, we started counting from 0 here. I'm going to 0, 1, 2, 3, 4, 5. Okay, so I want to stop it somewhere. So I want it to be less than 10. So I can choose to say let it stop when it is less than 10. And so what is the last part that's less than 10? That's 9. Or I can just choose to say let it be less than or equal to 9. It's still the same thing to still work fine. Okay, but let me just leave it as less than 10. Then the iteration, that's be adding plus 1, plus 1, plus 1. Now let's see what is going to happen here. So now we have to call something that will make the for loop active. All right. So I will call the array here. That means, but I will use I this time around. I'm not putting any number because since this I is 0 here, if I want to remember, for loop is something that to keep continue with the same pattern. So if we start with 0 here, to enter here as 0 and print whatever you want to print, then go back here as 1, then enter here as 1. So the process will keep repeating like that. So if I have array I equal to I plus 1, that means this partner, when the initialization where I is 0, that means this place here will be 0. Let me show you something like this. So that's R here will be 0. That means it's saying 0 I plus 1. Okay, remember the same I which is 0 will also be here 0 plus 1. So it will be 0 plus 1 again. And 0 plus 1 is what? 1. That means we've called one portion of our array as 1. Then to go back up to count again, that means this place will now change to 1. Okay, so once it changes to 1, that means this place then will change to 1 again. Then that 1 is changed to this I. Remember this place is I, so this I2 would then be 1. So to be 1 plus 1, which is what? 2. That means our position 2 of the array would have an element of 2. So that's how to keep going, counting till it gets to 9. Then it will stop the looping. Okay, so let me just print it so we can visualize what is actually going on there. So array, we're going to use percent %d since we're dealing with integers. Okay, so is initialized with the number ways to initialize it. As usual, new line. So the first percent %d will take the counting. So I want to take the counting. That's this first 0 that will be inside this our arrays here. All right. Why this next percent %d here will take the actual value. okay, of the array itself. That means I'm going to write array bracket I in this place. So if I let's print this and see for ourselves undeclared. Okay, we have I that is undeclared. So let me just quickly declare I. So int I. So let's build again. Okay, so this is how it looks like. So this is the first arrays. Array 0 takes 1, array 1 takes 2, which was what I was explaining here. That's the array 1 here that took 2 here. So same thing, once it enter here, array when I becomes 3, that means this place will change to 3. And that means this I here would be 3 plus 1, right? So that is 3 plus 1. And 3 plus 1 is what? 4. That means this place will be 4. That means array 3 will take 4, which is what we are seeing here. You can see array 3 as 4. So that's just how to use for loop to create your own array. It's kind of like faster way. Okay, so that's just one way to go about that. Now there's something called, now there's a way to check the size of arrays. We have different size for integers, for floats, and for double and for character. So character takes, I think, 1 byte. Float takes 4 bytes. Yeah, is this 4 bytes? I think integer take 4 bytes. Float should be around. I think maybe it depends on the operating system though. It depends on the operating system. I think different machine has their own bytes, 32-bit and 64-bit. Okay, so just for us to specify now, because this each of this array, remember this each of this array, each of them have their own integers like this. Like this one now is its own integer on its own. So if I am to ask you now that what is the array, what is the size of this array? That means what you'll be doing is that you have to count how many they are, which they are 10. That means they're like 10 times 4 because one integer holds 4 bytes. All right, so since we have 10, so just like saying 10 times 4, that means this whole array is holding 40 bytes of memory. So the memory size is taken as it is now is 40 bytes. So there's actually a way of also checking it anyway. So let's just quickly see that also. And let me just write the syntax of checking that. So to check that, just like putting the data type, I mean, so we're using the size of operator as usual. So we're going to say the size of, okay, so then the data type of that array that you are checking times the array size. Actually, is already obvious self because just like what I explained here, we know that one single array, one single integer has 4 bytes. All right, and then the array size is this 10 here. You can see the syntax here. Here's the array size. So whatever value that is here is the array size. So since we have 10 in number, that means you can say 10 times 4. So that will give us the total size in terms of bytes. So that is 4 times 10 here. So that is 40. That means this is holding 40 bytes of memory. That this particular array is holding 40 bytes of memory. Okay. So probably let's test that also to see it, visualize it as it's real in our screen. So, or should I use the former one? Let me see. Let me use the other one I've already created. Since this is already an array on its own, so I think we can still choose to use this one. So I can say print. So I'm going outside now. So print the array of, I mean it's 10 integers. So 10 ints. So the array of 10 integer has total of something bytes, okay, which I will use as percent %b. So percent %d bytes. So now that percent %d then will take, then the percent %d will take the, or we can choose to, well, there are two ways we can do this. Okay, since we know the format, who is that? I can't add anybody right now. Okay, I'm trying to see if I can, looking for a simpler way to explain this thing now. Okay, let's say for example, if I have another variable here, let me name this one as total bytes. So total bytes. Well, since we already understand that all of this, as since we know that the size of all of this is 10 in our mind, right? Which there are any number. Let me take this down because of space. Print this. Probably let me just comment this first. Okay, so let's just do something first. So if I'm to print the size of, and mind you, I even just declared total bytes here, so I'm not really specified or give total byte anything. So let me call you total bytes the variable. So in total bytes, I want to give total byte the size of integers, which you already know our size of integer is 4, right? So size of integer times how many arrays? 10. So 10. Okay, so now the size of ints, that is normally, let's just take the size of integer normally. So the size of int is something bytes, so percent %d bytes. We can quickly check that with our size of operator int, then close it with your semicolon. So let's run this and see. So we have the size of int is 4 bytes here below. Okay, so that's at least already know that one down. Let me put a new line at the start here just to put the space between that formal this printf. All right, so moving forward, sorry. All right, so next now let's print what value this would give us here. Remember, this will give us the total bytes of this whole array itself. So let's say print f the size, or let me say the array of 10 integers. That's the data types. Okay, so 10 integers as total of something bytes. Then that's this percent %d. I'll give this percent %d the name of the variable that I want to point out. Then semicolon. So this is a way of checking the size of the array. So if I'm to build this now, the size of array is 40 bytes. So it's that jam packed together. Let me create a new line here. So let me build this again. Okay, so the array of 10 integers has total of 40 bytes. So 40, since I've explained that 40, which since we have 10 here, and we know that 1 byte is 4, so 4 times 10, 40. So this is like one of the ways of printing out your numbers, to check the numbers of size of your arrays. Now, there's something you need to understand now when it comes to address. So each element in your arrays, like I think we've talked about address in the pointers aspect. So each element in these arrays has their own address, just like you are declaring your normal individual variable that have different addresses. Okay, so the same thing applies there. So each element here has different address. So you can just let's quickly just check that. So let's check the address of the first element of the array. So now the first element of the array is 0. That's the name of the array and our square brackets, then 0. All right. And remember, whenever you want to call the address, you want to check the address of something, just like I said the other day, you have to use the AND operator. So that's how to use to check for address. Okay. And the specifier, the format specifier you're going to use is percent %p. That's what you're going to use. Okay. So let's just quickly do that. So if I say print f, so the address of the first element. So our data is percent %p. That's what we're going to use. New line. So since we're dealing with address, then the AND operator, then the name of the array, which is R, then put our square bracket, then which position we want to check. We want to check the first element, which is 0, right? So let's print this and see the address. So you can see the address here. It looks like the real address, just like the address you've seen in my previous lecture in pointers. You can see that is kind of correct. So let's print another address also to confirm if they are the same address or they are different. So let me just quickly copy this. So let me print the last address, that is 9, I guess. Okay, the last, let me name this one as last. So build and run. So you can see the address are different. So which means each of those integers in those arrays have different address. Okay, they have different addresses like that. That's what it means. So all of them don't hold one single address. All of them have their own different address. Just keep that at the back of your mind. Now let's move to arrays and pointers, kind of like together. So let's see how both of them tally or mix together. So I don't know. Let me claim, should I, okay, you know what, let me first take question as to this aspect first before proceeding to the arrays and pointers aspects. Arrays and pointers. So that's what we'll take next. So before that, let me just quickly take some questions as regards to what I've already said here to be sure that everyone is following. So let me unmute. Okay, so anyone with questions though? Okay, it's not compulsory you put return zero in brackets, just so you know. But any question as regards, it seems there's no question. All right, I guess everybody's following then. All right, so let me just proceed then. Let me. Oh, someone just. Okay, you can unmute yourself and ask a question, please. Someone just raised up. Just unmute yourself and ask your question quickly. Pucha, like which stuff are you saying about doing with Pucha? Yeah, sure, sure. You can use character. You can also use floats. Your array too can actually be in characters, not just numbers only. So if it's character, then you have to declare it in characters. Okay. So that's just it. So it's not compulsory it has to be numbers. Just know that it must be consistent. If it's character, that means everything that is inside that array, everything must be in characters. And you know characters are enclosed in single column. That means even you can even convert. I think we can convert this to character also. I think it's possible. But it means we're going to put this stuff as, I don't know, single column. I mean, something like this. Yeah, yeah, sure, 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 sure. Remember, everything, just ensure everything is still in that. Even numbers too are part of characters, but that is if you put that single column, I mean, quotation stuff. So it will convert to character. So it's still applied that way. Okay, so I guess I've answered your question, right? Okay, so, okay. Yeah, mixing it up. String and character are different things. Characters cannot be like two letters, they are always single letters. Check that table. There's this table I sent in the group chat. So characters are one kind are single, can be a single number, single letter. But the major in short, let me just show you. Let me just do something here. So, um let me change this to car. So let's do some character stuff now. So that's B C D E. Okay, so remember characters, everything are closed in single quotes. So you can't put two letters like cats. This is not a character. Okay, so you have to be a single, either one or new line. Let me show you that table. Let me find that table. Um, okay, so these are characters as they are like this. Okay, so even a number can be a character also. So even a number, even these stuff too are characters. Okay, and capital letters are different from small letters. So all these are characters. It's not if when you're talking about strings, then you're talking about kind of like a sentence. So it's different from characters. Like there are two different things entirely. All right. So just don't mix them up, please. So let me just do example of character to see if we can really modify them as we have done for numbers. Okay, so if I say something like array, okay, this is 10. Okay, well, okay, let's say we have 1, 2, 3, 4, 5. So that's 5. There's something I wanted to say, but I just first let me hold on first. We've not gotten to that part. Okay, so let me first print this first. So print f. Now, since we're dealing with character, I'm just going to use percent %c. Then array 0. So I'm putting the first part here. So let's see if it will give us our A. Okay, it gave us our A. Now, if you remember that A also means 97. So let's see if I put 90, let me change this to 97. 97. And I will see, so it should still give me A. Wait, what's that? 97% C. Wait, he didn't give me A, he gave me 7. How is that possible? Let me check this table again. 97, small letter A. Okay, let me try 65. This thing is funny. It's taking the last number. I don't know whether probably I don't know if there's an issue with my code blocks or something, but it's supposed to give me that value. But those this even if you want to give me a number, maybe this place have to be a D. 53. I think there's an issue somewhere. I think I'm looking at this now, it shows that either we want to if we want to use something like this now as regards to these characters, either we use normal letters like this with the quotation marks without actually using number. But I'm expecting that since everything are characters, so everything needs to follow up that way since they're all characters. But it seems like it's not really applying that way. But let me modify it and see if it will be modified. So if I say array 0 equal to, let me say maybe z. Okay, so let's see if it will give me z. Okay, so it gave me z still. Okay, I think this is just this might be probably how arrays works in terms of arrays. Okay, I think we've seen the aspect of integers. So I think this is how arrays still works on its own. So I don't know. Is there any other question as regard to this, or are you saying something else different from this particular stuff that I'm writing here? Just let me know, please. Oh, I'm not sure. Can we just put car for this? Okay, let me see. I don't think I use put car though. But if I to let's try it. I know LS love using that put car, and that seems to customize people to always be thinking about that put car. Well, let me see. Put car. Okay, still run as Z. Let's put char new line. Put char 10. Okay, I think it still work fine. It still work fine. So this is how to go about it then with the put car. I think I'm more accustomed with using printf. I think it's okay for me that way, especially if you want to put some kind of statement or something, instead of to just put something Z like that. So, anyways, at least we've got to see that the put car also still works. But there's also one more thing I didn't mention though when it comes to this arrays aspects, like declaring arrays, which we are supposed to look at it like later on, not really yet. But I wanted us to first look at that pointer. But since we started talking about, I mean, characters. So since we started talking about characters, let's just move to characters. Probably we'll come back to that aspect of the pointers. Okay. So there has to be slides here. Okay. All right. So let's talk for the aspect of displaying arrays and characters now. Now, this arrays and character actually has its own unique style in a way. Now, if you notice, we have 1, 2, 3, 4, 5 here, and I placed 5 here, right? So whenever you want to do something like this in terms of arrays now, we always, in terms of characters, we always put this null, they call it null character. So we always put this, we put backslash, then place 0 there. So this stuff always needs to be there whenever you are dealing with characters. Okay, so it's just like a rule, it's just like a way of letting the compiler know where to stop when counting the arrays. No, when we're dealing with numbers, when you're dealing with numbers, you don't need to put this particular thing in numbers. When you're dealing with characters, you have to put this stuff in characters. Okay, and since we have 1, 2, 3, 4, 5, 6 now, so that means this place will multiply to 6. So this is actually the appropriate way. In short, before all the stuff we've been doing, when I didn't put this stuff that it was still pointing, it shouldn't even be pointing for me. It should have told me some kind of error that I should add this stuff there. You understand? So the real sense, this stuff must always be there whenever you are dealing with characters. Okay. So they call it null character. Yeah. So let's just see kind of like more example as regards to this whole character aspect. So let me do the same points, like the same format I used in that numbers part using the for loop and all. So let me create a new arrays now. Let me name that one array car, and probably let's make them 7 in numbers. So as usual, use your curly brackets and single quotes to put each of the letters, right? So if I write something like hello, so hello, so this will take some time to be typing one by one. Um, L, L, O, okay. Let me just put this semicolon. I think this is also a character on its own. That's exclamation mark. Okay, good. Okay, so we stopped here. So always then put that null character there. That's backslash 0. Okay. So now what we want to do, we want to just want to print them and see how which of them we are, just the way we arrange the integer aspect. So let's arrange it in that way now in this part using for loop. So I can choose to just say for I equal to 0. Now since we have 7 here, which means we are starting from 0, right? So that's 0 to 6. So we're not really using 7. So we can say less than 7. Then the last part, the iteration, that's I plus plus brackets. All right, so we want to output something. So we want to print. You can see the advantage of this printf now. Instead of using that put check, or you cannot put some kind of sentence. If I want to put some sentence in there, I have to use this printf. So now if I want to just print each of these arrays, like for the array of 0 and then the output of it side by side, just the way we did for that numbers. So that's array car. We have our brackets, like square brackets. Then I'll put here as %d. Okay, so contains. So I'm saying this, for example, now the 0 part should contain h, right? So I'm just write %d, or sorry, %c, since all of them are all clear characters. So I'm not doing any integers here. So our new line as usual. So the first part will take the normal iteration, the I, that is this bracket part, will just take the normal numbers that is counting here. While this one will be taking, the C will be taking the actual characters here of the array itself. Okay, so I'm just going to call the name of the array next here. So that is array car, then puts in that same value. Oh, sorry, puts I, since we're dealing with iteration here, which is the same I. So that means when this place is 0, this place will be 0, then this place also will be 0. So it will print whatever position it is, which is this h. Same thing will happen when this one is 1 to print e. All right, so let's just quickly see that. Okay, I'm not declared the I. So int I of my for loop, that is this variable I. So let me build again. I think I've not put semicolon here also. Semicolon. I think we are all good now. So let me build this. What's the error message again? Line 6, expected comma. Oh, sorry, I didn't put semicolon here after this character. So I think it affected this stuff somehow. So let me build again. Okay, good. Now watch something now. Remember what I said concerning this null character? You can see there's actually nothing after that semi exclamation mark here. There's actually nothing here. So what this stuff does is trying to let the compiler knows that it should stop at this hello. Okay, so what we're going to do now, we're going to print this as a string. That's what we want to do next. But I want to explain how the compiler prints it as a string. So it first looks through that array. For example, okay, how will I just fine, let me put 6 here. Let's see something. Mind you, you shouldn't put 6 here because like you have to make sure you count everything at that. That's 1, 2, 3, 4, 5, 6, 7. Then if I put 6 here, that means I've already limit the what the array list can do. But I don't know if this one will probably show me error. Okay, it's expected to show me error though, but look at the funny error it showed. This kind of mushroom stuff, which doesn't really make any sense. Okay, so it's just like an error. Just put that like pocket match. So on a normal way, we're supposed to write it as number of the elements, and always put this our usual null character. So the null character, the advantage of it being there is just for the compiler to know where to stop when calling this string. You can see it's in this empty place, then it will stop its counting. Now let us visualize this using normal print. So let's just print out our character normally now, just so you see something. Now, if I say print, let me print F. So if I say I print the string, remember when you are dealing with putting string, it's actually percent %s. Percent %s is the format specifier for string. Okay, so now to print out the array. So I'm printing out the array this time around. This time around, there's no need of you putting those this stuff there. Just write the name of the array there. So if I print this now, you can see it wrote hello for me. Then that null character, it then prints that null character just for it to know where to stop. So that's why I stop at this last exclamation, just like the way it's arranged like this. So that's how the string come out in this format. Now let me show you another way of to really explain how it really came to be this way again. Let me do the same thing using for loop again. As in, I mean this last line that I put here with string method now. Let me use for loop to do it, and you see the condition I will set for it to work that way, or else it won't work. So if I say for I equal to 0, that's the normal iteration, normal counting, right? So now I'm going to put the condition here. Now that condition now I'm going to say the array car, that's the name of my array normally, okay? Bracket I. Now I'm going to say it is not 0. That's when this array is not 0. Okay, that's how to read the statement now. So when array underscore car is not 0, and remember this operator and, which means both sides must be true. So and when I is less than, I think 7, yeah, since we're dealing with less than 7, then I plus plus. Now let me read this again. So now for I equal to 0, which is our normal initialization. Now I put a conditional statement here, which says that this for loop should keep running in as much as this array character is not 0. Remember, when you're talking about something is not 0, we're talking about this null character here now. No, when something is null, like something that doesn't exist, something like that, okay? So when this array character is not empty, something like that, or is not 0, keep looping, keep running the for loop. That means this two have to be true. That means to first check if it is not 0. Like for example, this one now, this first pass, h is not 0. Then check if I is less than 7. So this h is 0. So it's 0 is less than 7. So the two condition is true. So it will run h for me. So to keep going that way till when it gets to this last part, and this place is 7. So when it gets to this 7, to check this condition and check this array car 7. So then to now check it's, sorry, is this 7? It will be 6 rather. I think that would be 6 because we're counting from 0 to 6. Okay. So this is 7, we're counting from 0 to 6. So that would be, so once you check this now, you check this condition and realize that, oh, this is actually a null character. That means this place will then be false. But this one might still remain true. This one will still remain true. But you know the condition about the and operator, which means both of them have to be true for it to be true. So if this place is false and this place is true, it's still run as false for us. So it won't work. All right. So let me just quickly end up this for loop. So I'm going to print. So let's test it ourselves to really see how it works. So if I say percent %C, okay, so I'm putting a character, and this time I'm trying to print them as a string format. So car I, okay. So I guess we are good like this. Let's build this and run. You can say hello, hello. Both of them are still hello. That means when it meets that condition of that null character, it stopped. It stopped looping that stuff. It stopped at this position of 6 here. Remember, this is 0, 1, 2, 3, 4, 5, 6. Then you check this condition. This condition is not met because when the array is the condition say when the array is not 0, that means h is not 0, so it will loop. E is not 0, it will continue looping. L is not 0, but now we are in the null character, so that means this place is true. That means this place, that means it meets this condition here. That means it is false. Okay, here we then we run as false. Why only this one is true? So that means everything here is actually false. So I don't know if you get this. I don't know if you get this explanation, which I am giving here now. So what do you think about this explanation? Do you really get this explanation? Or any question as per this particular explanation part now? Yeah. Like what? Okay, you are confused with this sentence here, this command here. Is it that you're okay? Okay, what this stuff means is that you just like saying, okay, let me use something realistic now. Okay, you can keep eating this food in as much as the food has not finished. Something like that. So that means even if you take one spoon, there's still food there. You can still take extra spoon. You can take till probably you see nothing there, then you will stop taking it. You get, so this array car part, it will keep running. This condition will keep saying true because, for example, this first place is h. Then to check, once it's h, check this condition, because remember this I, what starting with I equal to 0 here. Probably let me use this comment part here. We're starting with I equal to 0, which means array, I don't know if you can see this clearly. Let me just write it normal. So array car 0, right? And we know that this is h. Okay. So we know that this is h. Then this condition has said, like when array car is not 0, which is like when array car is not 0, and indeed array car here is not 0, right? That means it is true. And I is less than 7, which this is 0 and 0 is less than 7. Like that's how the statement means. I don't know how else to explain it more than this. So when array car is not 0, keep doing this. So when this food is not has not finished, keep eating it. So I don't know, you can put it that way to get to understand what that statement means. So until when it meets that condition, then it can then stop. Okay, you know what? Maybe let me put this here. Let me put exclamation mark here. That means now I'm telling it to stop when it gets to this place. That means I think I shouldn't get this exclamation mark to print here. So let's see that. You can see there's no exclamation mark here. So that's just like an example of what it means, that statement itself. You understand? So it will stop once it gets to this exclamation. So it won't print this exclamation mark at all. So in as much as it's any other thing aside this exclamation, then it should continue. So just put it that way. So the loop can continue in any way it wants to continue, in as much as it is not exclamation. So the same thing applies to the part that may putting in that 0 here. So anything that can put anything that wants to print, let it print. In as much as that thing you are printing is not a null character, then stop. I don't know if you get what I'm saying now. Okay, so any other person with confusion? Okay, I guess there is none. So another way of actually, then if you notice, then this condition may look tedious in a way, like it looks like a stress. So you can just simplify it. So you can just simplify it by just putting it this way. So me just doing it that way, just for you to understand of the fact why the essence of this particular thing we're putting here. That's why I just needed to do it so you can see the essence of what it's really doing. So even if you do it this way, you can see it's how it's kind of like simple. So the compiler internally knows, in as much as you've already placed it here for it, so to understand what you are trying to say. So now if you are putting this condition for it to just print the array like that, when it gets to here by itself, it will know that it should stop without you really telling it to stop. So if I print this now, it still give me the same thing. You can see we still have the same hello and the semicolon is still there. All right, so you can see we have two ways. You can use this first way to do this, or you can just use your string specifier to do the same thing. So both of them will still give you the same output. So don't forget, when dealing with integers as the values here, when you're dealing with integer elements, don't put this null character. Only put null character when you are dealing with characters like this. Okay, so only when you're dealing with character, that's where you always need to put that null character and just and still include it when counting. Like this is 7, and we count each of the elements here are 7. All right, so that's just it about this displaying of arrays aspect. So let me just, since we're already talking about arrays, so let me just keep going forward as to this arrays part. So there's also something called multidimensional arrays. Why is this thing showing me? Okay, I need that big. Yes. So multidimensional. So we have multidimensional arrays. Now, what is multidimensional array? So sometimes you can get to see arrays that looks like this, that has like a nested array and something like that. I think that's a good word to even use. Something like 1, 2, 3. Then probably you have another nested one inside, like maybe 4, 5, 6. Then how do you think you can call or you can refer to this array? Let's say you want to change one of them like that. How will you break it down? So that's what we mean by multidimensional. So you can have two dimensional, you can have three dimensional. So I think the limit most times highest is 3. You understand? It can't be to make things more complicated if you are going beyond 3. All right. So let me just explain what this whole stuff is really about. Now, for example, we have something like this. But assuming we have an array like this, which is like an integer, okay? Let me just use integers. I think we've talked very well about characters. All right, so just for simplicity, I would like to use integers as the example here. So we have integers, and like just like that example of those numbers I put in just now that I just erased. All right, so we have something like, as usual, maybe something like simple like this. This stuff means we have two elements, something like 1, 2, right? We agree to this one. But on the real sense, we are counting it like 0, 1 in our mind, okay? So in the real sense, we're counting it as 0, 1. In short, to say that 0, 1 self, that means even the 2, like that extra 2, is just like the imaginary null character. That's why we didn't include it. So the compiler will always trigger it. That's why we don't see any need for integers or putting that rubbish, that null character stuff in integers. Because since one now is 2, as if the compiler already understand when it comes to integers, so we don't need to put that null stuff. So once we account with 0, 1, see that 2 part, the compiler assume that to be a null stuff. So to just stop at that, to just stop there and just print only 1 to false. So now this array now has 2 here, right? That's why we have 2 elements here. Now assume we have something like this now, array int 2, then I put another stuff here again, so something like 3. Now, you can see something different has happened here now. Now, let me explain what actually went on here. Now, we have two brackets. So we have kind of like a separate element in a way. So like this first part, we have two. Yeah, kind of like we have two separate, ah, is it two separate comma? I'm trying to look at how I can break. Okay, no, let me break it down one by one. So if I want to give this array a value now, in terms of like as if like a baby. Now I want to give each of them a value. I can just say, or probably let me use the code blocks directly to explain this. So I can just print it fast that way. Um, so I'm just going to erase this. So let's repeat that. So integer array int 2 3. Okay. All right. So now, in your mind now, like I want to explain how this stuff came to be. So if we have something like array int brackets 0, like remember this 2, I explained this 2 just now, where I said that this 2, the counting is like 0, this first one is 0, right? That means if I want to call this one, imagine I want to change this one now. What will I do? For me to change this one, I will just call my array name. Then since I want to change this one, I'll just say 0. Then I can change it to whatever I want to change, maybe to 5. That means this one here will change to 5. Agreed, right? So if I want to change this next one, this next two here, I will just say array int 1. Then I can choose to put any number there. That means the new array would be 5 and 10. All right, but then notice this thing here now. This place is 0 for that first one. This one is 1 for the next one as normal, right? Now coming down to this place. Now coming down to this one now. Since we have 2 here, this first part is just the same thing like this one. Okay, it's just like the same thing. So if we have something like array int 0, so I can maybe let me just assign this one as 1. Then I have something like array int, okay, sorry, like array, I'm talking about this first part now, array int 0. Right now we still have something here. I almost forget that part. So we have something here which is 3 in this part now. So what it means here, I'm just going to put this part of 3 like a nested loop, or probably let me show you the real output of what this array means here. So this array here that I'm trying to do is looks like this. I want to do something like 1 2 3 comma 4 5 6. Now okay, so now I have to put comma in each of these 1 2 3. Sorry. Now these 2 that you are seeing here is these 2 brackets that are inside. These 2 square brackets. Now these 3 you are seeing here are the 3 things that are inside of each of them. So that means if I want to change this one here, this particular one, I'll first call the position of this big array, which this is the first position here. That's this 1 2 3 within this square bracket is the first 0, while this next 4 5 6 bracket is the 2. Okay, now since I want to change from this end, this one, that means I'll start from the 0 here. That's why I put in this 0 here. Now that is one step. Then I will enter inside this curly bracket, which is this 1 2 3, inside the curly bracket, and count again, start from 0 again. That means this one again is 0 1 2. That means the 1 here is 0, the 2 here is 1, the 3 here is 3. That is in terms of counting it now. So that is like 0 1 2 rather. Okay, so that means I can then put this place as 0 0. Then I can choose to modify this place. Then I can choose to put maybe anything here. Then to modify this particular one. Now the same thing goes if I want to modify this 2 here. I'll first take the big. Let me space it up. So, although you won't space it up like this in the real sense in your code blocks, but let me just space it just so we can understand what we are doing here. So now the next one now, that's this 2. If I want to modify or refer to this 2, first this is the big array. This is the first one, and this is the inclusive part of it. So I'll first enter the big array. This whole place is 0. Remember, we already count from 0. So this is 0. This is 1. Okay. So that means since I want to change 2, 2 is where? 2 is within this 0. Okay. So that's why I'm going to put 0 here first. Then I will now enter inside this new array inside it and start counting again from 0 again as usual. That is, this is 0 1 2. That means this 2 is actually 1 in terms of counting. Remember, 0 1. That means this part then would be 1. So this is where the position of 2 is. This first one here is where the position of 1 is. I don't know if you get what I'm saying. So that's how you just be doing it for each of them. Same thing applies with this theory. So that means this theory then would be array int 0, since it's the first one inside of this value here, then we enter inside this new array inside to pick what 3 is, which 3 is in position 2 inside this other array. Remember 0, 1, 2. So 3 is in position 2. That's why there's 2 here. So this is where 3 is. So the same principle applies to this next part here. So now if I want to change, or if I want to call this 4 here, I'll first check the big array here, which here is 0, here is 1. Okay, so that means my first write up here would be the name of my array, and I'm going to write 1, which means I'm first calling this whole big place. Then I want to enter inside it and take one element inside it. So this one now has its own array inside, which is like a nested array. Now the same counting again, start from 0. So that means this 4 start counting from 0 again. That's 0, 1, 2. Okay, so that means 4 will take 0 parts. That is 0 position inside it, and that's where 4 is. So the same thing goes to 5 and the rest. Okay, so that is int 1, since we're still dealing with the 1 position. Sorry, 1. Remember, this is 0, this is 1. Then the 5 enter inside 0, 1. That means the 5 is also 1. So that's 1, 1 equal to 5. Then lastly, int 1, 2, 6. Oh, so this is just how to identify each of them. So this is what we call two-dimensional arrays. So imagine how two-dimensional arrays is like this now. Now imagine having three-dimensional arrays also. So it's just like the same. Just understand in your mind that the first one that always come, like the first, or like what do I call it, the first position or the first square bracket that always come is usually the first major big bracket that takes everything, that contains everything, which is like this first big bracket here. You understand? So whatever value this first big bracket, just keep it in your mind that that is always the first major big bracket. And since this one is 2, I mean it will hold 2 first. Okay, so it will hold 2. Then inside that, each of those 2, anything that happens there will determine. So this one is 3, that means there will be only 3 things inside. I don't know, I feel like maybe we should attempt 3 dimension now to see how it may kind of look like. Or let me first ask, any question with this particular one? Like, who have any question with this understanding each of this stuff I explained here now? Any question? Okay, I guess there's no foodie logic. Okay, so I guess there's no question. I guess everyone is following it then. Okay. Okay, so simply, so that's just how it works in terms of dealing with arrays. Okay. So now let's just see. Now you see this stuff now as it's written this way. It's also okay, but it's for best practices in your mind or in your jotter. It's best to write it this way. But then you can also write it this way in your normal code blocks and still take it as the same thing. Something like this. So something like that. So let me just quickly add. I think someone wants to join. All right. So even if you write something like this, it will also accept it this way as a two-dimensional array. But just that this one looks confusing because someone can just take it as a single dimensional array. So that's why it's good to just know how to like split it so it will look so to make more sense to you whenever you want to write it in your own rough sheet. You understand? So let's go to our code blocks and just see an example as regards to these two-dimensional arrays. Now, for example, if we let me just create a simple two-dimensional. So I'm just name it two-dimen or two-dimension array. So let me put this one as 3, next one as 5. Now to create an array list. Now let me create arrays of like 2, 3, 4. Now since this place is 5, that means I'm going to end at 5. Okay. That means this 3 will contain 3 different square brackets on its own. Something like this. So we have one square bracket, comma, then we have another square bracket, then we have the third square bracket, Okay, so this three square bracket is just like this three that you are seeing here. Okay, but you know the recent, we want to count to, we say 0, 1, 2. All right. Now, this 5 now is what will be inside each of those nested square brackets. So since we have 5, that means we have 5 elements inside them. So in this part, I just want to use normal numbers. So I did this so I just this is 1, 2, 3, 4, 5. I can change this one to something maybe 10, 20, 30, 40, 50. I think that's 5. Then go to this next one, maybe 100, 200, 300, 400, 500. Okay, good. So this is just a good example of how two-dimensional looks like. So remember the first part always counts how many square brackets that will be inside. That's how many nested square brackets. Yeah, we have three, right? Now the next one will take the number of elements that will be inside each of those three. Which of them must be 5, 5, 5. Which of them are 5, as you can see here. Okay. So now let's quickly do something. So if I want to use a for loop now, and I would like to print each of them. So I want to print each of them. This. I think there are three. Okay, yeah, this. So just like I said the other time, you can choose to remove all these square brackets later on. Like after you've analyzed it this way, then you can just remove each of them like this. So it won't really change anything. So even looking at it like this, you notice each of them have their own pattern. This is just single, 1, 2, 3, 4, single digits. Why some look like double digit, 10, 20, 30, 40. Why some look like triple digits, 100, 200. So they have some kind of like pattern. Okay. So now let's test something. So if I say for I equal to 0, that's our normal initialization. Then I less than 3. Now I'm starting with this 3 here. Okay, remember this 3 here means we want to count this our 3. Remember it's 0, 1, 2. So it's stopping at 2 in terms of our counting, programming counting way. Okay, but this 3 is just showing us the length of the arrays itself. So less than 3, then our iteration as I plus plus. Okay, now what I want to do now, I want to print each of them. So I want to print 1, 2, 3, 4, 5, and I want to print 10, 20, 30 under it also. So I will just put a new line. So you can choose to use putcha, you can use printf, your choice. Okay. So let me just use the new line just for new line sake. If you want to use putcha, you can just put your putcha 10. I think 10 means a new line in character. Let me see 10. 10 in decimal. Where's that new line symbol self itself? I don't seem to find it here. And yeah, notice this stuff zero. You can see zero here means no in terms of that character stuff that we were talking about the other time. So this 10 anyway should be a new line. So I don't know what they mean by this LF stuff they're writing there. So it's actually a new line. So just another way of doing the same new line stuff. Or you can just choose to put that character itself using your single quotes and put the new line like this. So both of them will still work for you. All right. So now I'm putting a nested for loop again inside this place. And this time around, I'm going to give it a different letter. Remember, since this one as I, so I'm going to make this one as J this time around. I can say J equal to 0 and J, since which will be this next part, which is this 5. So I'll say less than 5, then I plus plus. Okay. So now, which means it will first go inside this major one before it ends inside this other one. Okay, so I will soon explain how the loop works. Just don't worry, I will explain the steps of how the loops work. So now I want to print D. So percent D, since they are all digits. So I want to print that as integers. So I want to print percent D. So I'll call my arrays. So I, the first one will be for the I as usual, which is this 3 part. Remember this I less than 3. While the J is taking this second part. So that is J in this second part. Okay, so this is a way of even, remember we removed those curly bracket stuff. So since we remove this curly bracket stuff, we've used this for loop to kind of like create our own internal curly bracket to make the program knows that this is just not a single loop. Because we can just look at this now and just think this is just normal. Okay, this is normal loop. Just okay, how many is this? 1, 2, 3, 4, 5. That's 5, 10, 5, 10, 15. Instead of us just maybe cleaning this now and writing 15 here, because it's actually possible to live with this with like 15. But then in our mind, we want it to be two-dimensional. So that means we put 3 and do it this way. That means for us to let the computer know that this is two-dimensional, that's when we need to use this for loop that we are doing now. Sorry, let me. Okay, I thought I saw someone wanting to join. Okay, so that's just how we are trying to let compiler know that this is a two-dimensional loop, not just a two-dimensional list, not just a normal single list. Okay, so now we're letting it know using this for loop. So this first for loop, we test this first 3 here. While this other one, we test this 5 inside it, breaking each of them into sections. Now let me explain how, or probably let me first run this so you just see how the printout looks like. Then I will explain how it gets to be that particular way. Let me just create a last new line. Let me build and run. Okay, I've not declared I and J, so let me quickly declare them as int I J. Build. Wow, it's running like infinite loop. Probably I need to stop it one way or the other. Let me check something. I think something might be wrong somewhere. We have I 3 for I is equals to 0, less than this. Print new line. Okay, for J equal to 0. Oh, I'm supposed to put J here, not I. Okay, okay, okay. So let's try it again. Okay, good. So these are the numbers, although they look jam-packed together. Let me split them. So I'm going to increase their space by putting this precision stuff. I think I mentioned this in one of my videos. So to just give a space at the front. So yeah, this is space. Now we have 1, 2, 3, 4, 5. We have 10, 20, 30, 40, 50. We have 100, 200. Look at the arrangement now. Look at how it's kind of like break each of them into sections. Now let me explain how these points take, like how it came to be this way now. Now looking at this first for loop, we have that I is equal to 0, right? So since we have that I is equal to 0, which is the first thing, then the condition now states that I is less than 3. Then we do I plus plus. So now we first start with I equal to 0 in the back of our mind. So I is equal to 0. Since it is true that I start from 0 and since 0 is less than 3 in this condition, 0 is less than 3, that means this whole place is true. So the loop will enter and print a new line. That's the space. Can you notice there's a space at the top here? There's a space at the top here. That is this space here. Or probably let's just get rid of it. Probably we don't really need it. So that it won't cause confusion. So let me build this again. Oh, okay. Since we need it, so I can bring out that write up better for us. Or it won't write it in this unique way for us. Okay, so it brings a new line, which is this new line we are seeing here. Okay, then it enter inside this new for loop to check the condition. Then the J is initialized as 0 and this J is also less than 5. Remember that this for loop has already started with I as 0. That means somewhere we know that I, let me remove these comments so that I can see what I'm writing well. Okay, know that our I starts as 0. So it is somewhere, remember this our I, we are dealing with this part here. So that means we're just trying to say two-dimensional array of this first part is 0. That's what it means here. So that's the first thing that just happened here now. It's 0. So that's the I 0. Then we'll print a new line. Then enter inside this new part of J. So we want to deal with this new part now. This new part of J. Now they said J starts also from 0. That means we have 0 in this next part of J. Then remember one thing about nested loop. The inner nested loop have to loop finish for it to go back to this beginning. So that means since you have a nested for loop inside this place, that means this place have to continue its own first before it will go back to check this other condition. So since we have j is less than 5, that means remember j is started from 0. So we have j is equal to 0, j is equal to 1, j is equal to 2, j is equal to 3, till j is equal to 4. So what I'm trying to say now, that means from this place now, I'm expecting to see the next one. And the next one here should be something like 2 dimension. The 0 will still remain because it first started with this initial for loop. But this one will keep changing. So you can see 0, 1. Next one we're going to have 2, 3, 4 till get to 4 here, till meet this condition. So once this condition become false, it will exit this for loop and go back up here. Then this place will not change to 1. And remember, once it changes to 1, that means we are dealing with this new position of 10, 20, 30, 40. That's why you are seeing those 10, 20, 30 under it. Yeah, that's why you are seeing that. So that's how it works. So after you start from this I, starting with this 10, 20, 30, which to do 5 times here inside. So to do 5 times, which are these 5 results here. So once it meets this condition again, it will break out of this inner nested loop and go back up and test for when I is equal to 2. So when I is equal to 2, that's when you now see this last part here, which is position of 2 here. Okay, so is that 2 that will then enter here, and you now loop another 5 times here, which prints 100, 200, 300, 400, 500. So that is what is actually happening in this place. So probably let me just break this down just like the way we first see that, so we can really understand each of the sections well. So this is just how it is now. So you can see this part is the 0, this part is the 1, this part is the 2. Though we might have 3 here, but now our inner counting is 0, 1, 2. We don't count 3 inside. The same thing will apply with this 5. So we have 0, 1, 2, 3, 4, which are the inside here. We have 0, 1, 2, 3, 4. The same thing applies to each of them. So I think that's just how the stages works when counting, when dealing with for loop and nested for loop. So the nested one have to run its own course, finish, before breaking out of the loop, then continue from this beginning again. Till when this full place is false, then all the loop will stop. That's when everything will stop. All right. So I don't know if there are questions as regard to this particular multidimensional stuff I explained here. Anyone with questions, please? Mm, mm. O- Okay, it won't end. Okay, is it because of less than, as in j less than 5? We're expecting it to stop at this 4. Remember when I said the counting starts from 0, not from 1? Then that means the element will still remain as 5. Yeah, just use your hand to count now. 0, 1, 2, 3, 4. There are 5 elements. So that's why it will still print all these 5. So just ignore this real 5. It's not saying this real 5 is really working. Like I can choose to just say less than or equal to 4 and to still give me exactly the same thing I want. You get, or you are still okay, or what aspect? Okay. No. After it's got, remember, imagine from this part now, when we got to this 5, eh, when we got to this 5, the j was 4. That means this j here was 4. You understand? So once it was 4, it's looped, then it completes that 5. Then the next thing to now check for j is 5. But since j is not less than 5, that means this space is false. So that means to break out of this loop totally and go back to this beginning. And then remember, this beginning initially started from 0. So once you go back to this begin to always will always increase. Remember, we have I plus plus. So this place, instead of it being 0, will be changed to 1. And when we deal with 1, that one is the second part of the array. Then the next, after it happened again, next one that will be 2. The 2 is this last part of our array here. Remember the array numbers here, we have 0, 1, 2. You get it now? All right. You can just maybe later refresh the video when I upload it. So, well, I'm glad you at least you get to understand that part now. So, any other person with any question as regards to this, please? Okay, I guess there's no question. So let me quickly do another last aspect as regards to this same array stuff. Because that's as if this, well, this array seems kind of a bit complicated and complex. But there's also something now called, if you notice each of these array we've been the ones specifying the limits. Like what I mean by that, like when we call any array now, probably we name an array, I create this array, then I put my own limits because I know the list I want to put inside, right? So I put 2, 5, just random numbers, just to ensure that they are all 5, which here they are all 5. Now, there are some cases that you don't really know the limits. Okay, so how will you notify? How will you put it when you don't know the limits? Whereby the limit may even be changing, whether it will be the user herself that is even putting those new lists, or if you want to be adding new one at the back. That's where data structures come into play also, which later you're going to look about data structures in C programming. So they're all programming like JavaScript, Python, they have their own data structure. That's another broad topic on its own self. So the knowledge of this is very, very vital, whereby we are not limiting the array with what we want for our own self. So which means it can change to something else also. So for us to do that, the way we notify it is just to use, we're going to, instead of us specifying the number inside, just like the 5 I put inside there now. So I won't even put 5 or any number there at all. I'll just clean that and make it seem as if it's like an empty value inside it. So hold on. Okay, so I'll just erase this part here and just leave it this way. So that's how to notify for, that's how to put unsized array. Now let's just see something now. Let's just print the normal size of how to check the size of our array. So if I'm to print the size of this array, that's percent %d. I say size, our size of operator, then the name of our array, which is just array, right? So we have 1, 2, 3, 1, 2, 3, 4, 5. So since we have 5 elements, and we know that for integers, one like integer declaring for one declaration of integer is 4 bytes, right? That's 5 times 4, which is 20. So that means we're expected to see 20 here. 20. Now we can just choose to be upgrading it, maybe put something else, put another value. So we've added new elements. So if we check it again to increase to 24, because it's adding as 1. Remember, plus 1, each of the elements are like new integers we are putting inside. So it will be updating automatically that way. So we have 28. So the next one will be 28 plus 4, right? If I put a new one down now, it will be 28 plus 4, which will give us 32. So that's just how to put on side array. You want to, in case you are not sure of the limit of it. Okay, so what this stuff does, it just creates a bigger memory size for you automatically, and it will be expanding the memory whenever the array list is expanding. All right, so that is what just all the it takes about the aspect of putting unsized arrays. So in case you have any array that is kind of like big, so let's see how to also do the same stuff using for loop. Yeah, so let's just list each of these unsized array using for loop. There's something I want to show you, because I don't know if you've noticed something. Yeah, let me just show you. Let me go back to what's one of our codes. Just go back. Now, if you notice, we'll be using like a, just like what I said about our list here, that we're the one specifying the limits here. So now I've showed you how not to specify the limits, whereby the limit can be exceeded, like it can be going, and to still not run any error for you. Now, just saying we will be specifying limits here, saying we will be specifying limits in our conditions here as 3, limits here as 5. There's also another way of upgrading this condition so that it will tally with the unsized array, something like that. All right. So that once the array is increasing and you are using for loop, the for loop 2 should be modifying as the array 2 is increasing since you are not sure of the limits. So that's what I want to show you how to do next. Let me just erase this. So let's quickly just do that one. So let's say, for example, we have an unsized array that we don't know the limit of. So I'm just going to leave it like empty that way. Now I'm going to put my curly brackets and put whatever values of arrays. Let me just put normal numbers 1, 2, 3, 4, 5. Now, you know that whenever I want to use that for loop, like if I say for, we'll start with our normal iteration, like I equal to 0, right? Then the next part, we then, let's say for example, assume we put 5 here. We have limited this array already as 5. That means we cannot increase it more than this 5, right? Then I will now put something like I less than 5. But you know that in the real sense, this is like 4. Obviously, it's running from 0 to 4. 0 to 4. Okay, which is like the whole complete element itself. All right. But just physically looking at it, the length is like 5 numbers. You understand? So that's why we're putting this 5 here. Okay. So don't get confused about this. So now, these two are limited. The 5 here is limiting this list. That means I can't expand this list. And also, this 5 here is following the condition that this list is not, can't be added, like any extra thing can't be added there. Now, there's a way to modify it. So, as usual, whenever I remove this stuff, that means I've made it on size, which means this can keep expanding as whatever you can keep expanding as adding more things, whatever stuff I want to add. It doesn't really care. But for it to be expanded, that means I need to make this one to expand along with it, this condition. So I need to expand that. So I'm just going to name this one. I can just name this one a new variable, which I can just call it as length. Then I plus plus. Now let me explain what this length needs to do for me. You can actually use any word. It's not compulsory to use this word length. Okay. Now I'm going to state what the length should do. So I'm going to state that length as a variable now. Now that length should do this a division sign for me, and the division size sign is the size of the array divided by the size of one array. That's the size of integers, since we're dealing with integers. So this is what it should do for me. Remember, when I'm talking about size of array, it's taking, let me reduce it to this 5 and explain this formula I put here now. So size of array, the size of this full array, we have 1, 2, 3, 4, 5. We have 5, right? I know that one array is 4. That's 5 times 4, 20, right? So we have the size of this equal to 20. Okay, that means the size of all of this is 20. That means we have 20 here. 20 divided by, then the size of integer, the size of 1 is 4. So 20 divided by 4 is what? 5. So that means, and indeed, this place is 5. You count it 1, 2, 3, 4, 5. So it's just as if this place is 5. So the length took 5 in a way. So now watch this. Let me increase this now. If I increase this one now to 6, now what it means that the size of the whole array will then be 24 since I've added 1. So to add as 1 as 24, that means this will be 24. The size of int, which is for the single one, is still 24. I mean, it's still 4, right? So that's why the 4 will still be there. Then 24 divided by 4. So that will give us 6. So it has modified since this whole place is 6. That means this length is 6. So you can see it is following, moving. So as you are increasing, it is tallying with this variable of this formula here. Now, keep this one. There's this one important thing at the back of your mind you need to know. If assume we are dealing with characters now, assume we are dealing with characters, and let's just say, oh, this is like extra stress. Let me just do this thing first. This whole quotation mark of it itself stressful. Now I want to explain this now using the character in sense of character, so that I won't just limit your knowledge with this array stuff. I mean with integers method. Now the same applies to this character now. So this character, that means I'm going to change this place to car. Okay, but this size of is still intact of the array. Now we have how many characters? We have 1, 2, 3, 4, 5, 6. We have 6. And one single character, what is the size of one single character? One single character has 1 byte. So that is 6 times 1. And 6 times what? 1 is what? It's still 6, right? So that means the size of array here would then be 6 divided by the size of one array, which is 1. 6 divided by 1, which is still 6. I mean, this space is 6, which indeed is still valid with this 6 here. So if I choose to increase this one to something else, maybe another new one, so this will then be 7, right? That means the size of array here is 7. So 7 divided by 1 is still 7. So this whole place is also 7. So that means this length is 7. So that's just how all of them will be tallying. Just know that whenever you're adding new, when it comes to character, we're adding in 1, 1, 1, because each of them have 1, 1 byte. But when it comes to integer, you're adding in 4, 4, 4, 4, because one integer is 4. Okay. So don't mix integers and characters in terms of how each of them works. So they store in different ways. So this one will add any one thing we increase here, we're counting it in 4. So if I put another new, if I put 9 here, that means this space 1, 2, 3, 4, 5, 6, 7. This is 7. That means 7 times 4. 7 times 4, that's 28. So that's how to be adding plus 4, plus 4, plus 4, on and on. So I believe you understand this whole concept now as regards to how the difference between the characters and the integers aspects. So that is how to also modify the follow. So the length will be updating with this formula. In as much as whatever change here, it doesn't really matter. The length will also update with it. Okay. So then we can just choose to print %d array I. All right. So probably let me just modify. Okay. Let's just leave it this way then. So let me build and run this. Let's see. Undeclared. Okay, I've not declared some of all this stuff I'm even putting here. Even this place I'm supposed to change it to integer. Okay, let me declare my variable length. So length is an integer. I think we have a follow that is I. So let me add I also. So build and run. Okay, so we can see the way the output is here now. So it prints out what is inside that list. Okay, just like how it was printing the strings for us. Okay, so that's just exactly the same thing that's happening here. You want them to be spaced, then you can choose to put a space here. Maybe if I make this one 3, I think the 3 should be inside the percentage, something like this. So if I build and run this, so that's the space there. That is, if you want to give it a space. So this is just how to create an array that can expand more than its limits. So without you limiting it. So I don't know if there's a question. Do you have any question as regards to this aspect on about unsized arrays? Any question as for this part, please? I think this is the last part. Okay. Okay, what's your question, please? Yeah. Yeah. Yeah, yeah. Yeah, 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 yeah. Yeah, that's a good question. You see, I didn't even notice. So yeah, you should actually be putting like probably next whenever like I'm expected to put that no at the end. Like assuming all those okay, assume we still have those semicolon, that single column, I mean quotation stuff I'm doing now. So stuff like this, then I put that no stuff, yeah. So the changes you'll be doing, anyways, the changes you'll be doing will be at this part, this portion. Like the additions you'll be doing will be like here. The null will still remain where it is. I don't know if you get what I'm saying. Something like so something like that. That's what I you can say I slip my mind. So that's one of the things we just need to always remember this null stuff. But I don't know, this code blocks might even run successful for me, which I don't know, it's supposed not to be. But when you now want to test the program, you now be wondering why it's not really working in the real sense. So we just need to always remember. I'm glad that you even noticed that. So that means you really pay attention to that part of the lesson. So yeah, thank you for that correction. It's a good correction. Is there any other question as regard to this part? Okay, I guess everyone is following now. So there was something I wanted us to do before I divert to characters and all of this. So let's just close with it. So the aspect of what I name it again. Okay, I've deleted the stuff. So the aspect of arrays and pointers. So that's what we are going to do last now. So dealing with arrays and pointers together. Okay, so I believe I want to believe everybody understand the pointers, like probably the last lecture I did. Okay, but I don't want to go back to explaining how pointers works. Okay, so I just assume everyone understand how our last lecture works. Okay, so now if I assume I have an array list of which I name as character. Okay, so a character list, a character array now which I name lists car, something like that. Then I give it a 10. Okay, so I give it a 10 here and put this space here. Then probably remember I'm just declaring here. I've not done anything special. So let me declare a pointer. I'm just naming that ptr maybe ch. Remember to declare a pointer, you have to put that asterisk. That's the reference operator for it for the computer to know what the compiler to know that this is a pointer. Then so if I'm to call, remember pointers store address, okay? So the store address that's ptr. That's if I want to call PTR now, say PTR ch is equal to the address of the list. Okay. But the funny thing now, something just happened now. The address of the list. Yeah. So which is but one thing you need to note now when it comes to lists is that once just calling the name of the list like this, like just calling the name of the list like this is already calling the address. And now pointers always, when it comes to this, pointers always first of all take the very first element in the list, which is the first element. That is just like saying it takes the zero part of the list. That's the address. If you want to write it this way, that means that's where you must put that your and stuff for address, just so you know. So you can either choose to write it this way. That's for the first, taking the first element, or you can choose to write it like this. Just the name alone. Automatically, it will just take the first one for you, the address of the first one. That's what will print out. So either of this way, it will still print out correctly for you. Okay, so that's just how. Now, I think there's a way then to increase the position of the address. Well, I guess we'll look at that later on. But let's see how this particular stuff I explained. Let's visualize it here in our code. So if we have int, I named that one as ptr ch declaring. Then we have another one. Okay, now we're dealing with characters. Can I name it arrays or this? You can just name it lists. Ch 10. Remember that 10. That 10 is the no character part. That's the last one. Okay. Um. Okay, I think that's all for this part. So now let's create. Oh, no, better still. Because if I'm to be using this character, I will need to write the values of each of them. I need to write the values. Let me just write the values. Of that, I prefer just using integer to make it snappy for us. But instead of not writing the value, I'm using that single quote stuff. That was like another stress alone. So let's just use integer this time around. Okay, so int list. Let me change it to int. So 10. That means now we have 10 numbers. Okay, that one works faster. So that means let me put my list of 10. So that means let me just use, I can choose to just put those 10 directly here. That's like putting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or if you want to use a for loop, you can use a for loop to do it. Either ways, I've explained how to use for loop to do this stuff to print the whole 10. So either ways, you still get it correct. So we have our pointer and we have a list of 10 here. Okay, good. I guess we're good to go. Now, I want to call my pointer, which is PTR int. And remember, pointer stores address, right? And remember what I said the other time, that once you just call the name of the list, just like that, it assumes you are calling the address of the first portion of the list. That's what it assumes. Okay, so it's calling the address. So let's really test that to see if that's what's going to print out for us. So let me say print f. Let me let me drink water since I'm losing my voice already. All right, so print f. So let's say the start address, the start address of the array. And remember, when you're dealing with address, so I'm going to use percent %p. That's the format specifier for the address. All right, so we're taking the address of which address are we taking? Okay, let's take the address of, remember, pointer to has its own address. We have the left value, the right value. This one has its own address, and it's taking this value address here. Okay, so probably, okay, maybe let's just see the address of this int here, the pointer int here. So let me just copy this. I'm just going to use it again to print the value of our pointer itself. So I want to print this time, and I want to print the value of the what the pointer is pointing to. So the value of the first element. Okay, so remember I said this. Remember pointers. Whenever if I call, I remember saying this that time when I was teaching pointer, that if I say something like ptr int, that means I'm going to enter inside this whatever address this is and fish out what is living inside that address. And since this one is the position of 0, that means I'm going to fish out 1. That means this place is having a value of 1. Just keep that means you can also choose to modify it and put it as 5. Then this inside here will change to 5. I've explained this aspect in terms of pointer. So the same logic applies to this one. So now if I'm to print the value of the first element using pointer, I think the first element is an integer, so %d. So I'm just going to put that asterisk here to see what is really inside it. Let me just comment this place. So let me print this and let's just see the output of this part. So you can see the address of our pointer here. That is this address of our pointer here. This is it here. Well, we already know all variables. Since this PTR is like a variable, so it has its own address. Now the actual pointer, which is this asterisk stuff, is now entering inside this address of the value of this pointer, which is holding with this list int. Okay, which I told that list int automatically usually take the first elements here, which is 1. So it enter inside it and take that 1. That's why you are seeing 1 here. So I think we can choose to modify this. Want to modify this? Maybe give it 500. Let me remove the comment sign. So let's print and see if it will be updated, if the list will be updated first. And the first list part, can see the first list part has also changed to 500. So it's no longer this one we are saying. So we've changed it to 500. So that's just like another way of doing it. So that's just the application of how this pointer works. Okay. So you can choose to label it this way to call. But now I think to call different sections of the list has its own format. I think that's when it involves something like you'll be seeing stuff like +1. I can't remember how it applies, but it's something like plus signs to really notify how to enter inside. Let's say this one now, you can see this place is 2. Okay, let's do this. Let me remove this part now. Okay, first of all, look at this. We know that PTR int, this pointer int is 1 currently. No argument about this, right? Since we know that it's taking the address of the first element. Remember the address of the first element, which is this one here. I mean, the address of the first element. Now, this is an integer. All of them are integers, and they have their own different addresses, which we already explained earlier in this particular lectures. Each of them have their own different address, okay? So now, enter inside this first part, this first portion of this list int, which is this major address here, it took the first value, the first element, which is this one, that is here. Now let's take for example, now I want to modify these two. How will I do that? That will be the next thing, because even just calling the name of the list or the array alone is only solving this issue. It's not solving the rest for me. It's only solving the first one. How can I do that? I can modify this, or I can modify this, or I can modify this. That's where the question comes into play. Then to do this, that's when you now see us doing something like percent. Then you call the name of the pointer int. Then you will now say plus one. So you are giving it plus one, like you are pushing it in a one step forward in a way. So you say plus one equal to, then can give it a new value. Let me just make this one as let me say this is 20. That means you see this 2 here. I've modified this 2 to 20. That's what it means. Okay, let's test that to really see the output. Let me modify, let me change this place. That means, sorry, let me change this place to what is here. So if I put the brackets, and I put plus 1. Remember, I've modified this place to 20. I'm expecting to see this place change to 20 now. Like it should print out 20 for us. So let's see. Oh, I forgot to put the last bracket. Okay, so let's build this again. So you can see this is 20. This is actually the second element. Sorry, let me just change this. This is the second element. So that's how to tap into the different elements like that. So the second value, we've updated the second one. So instead of these two, we've changed it to something else by adding that plus one, by increasing the step. So that means if I want to change this three, this next step, I'm going to say plus three. Okay. So I'm going to say plus. Okay, sure. Let's test this. Remember, I first did plus one for us to change to this two. Now, if I'm to do something like this now, for us to be really sure that it's really the list that is changing, since you know this is our major list, right? So we can choose to test the list itself by just running our print percent %d, and then we want to print the list itself. We don't want to print anything related to pointer, and I want to see our list going to be sure that it's really changing, right? I will know that this 2 is in 0, 1, is in the 1 position, so I'm going to put 1 here. So now let's see if this value will give us this 20 that I've changed with my pointer here. Let's see if this particular value down will give me 20. You can see it still give me 20. Look at it, this is 20 here below. So you can see that the list indeed is actually changing through that pointer. So that's how we can tap into each of them. So this first one now, we tap into this one. So if I want to tap into this 3, I will say plus 2. That means it will modify this 3 stage. That means this 2 will still remain. This one will be changed to 20. So that means let's test that now. If I change this one to 2, so let's test to check if the value will still be 3 or 2. Then I want to print this one also. So I'll change this one to 2. So we're going to see that everything will change to, okay, that's actually changed to 20. And mind, look at the one that changed to 20. This is position 2. Okay, this is 0, 1, 2. That means our 3 here changed to 20. So that's how to be increasing it, how to tap each of them using that pointer stuff. That's how to just connect pointers and arrays. So I believe you understand this part. Just that naturally, pointer take only the first one. So that's why there's a need for us to manipulate for us to be able to take the next one. So that's what they will be doing using this additional sign to be giving it a one step forward. Okay. So the first one move to the 2. If you want to take the next one, 2 is moved to 3. Next one, 3 move to 4. That's how you'll be doing each of them. You want to multiply any part of the array using pointers. So that is the explanation about arrays and pointers. Is there any question, please? That's the last. This is like the last thing right now. So any question as regards to this one? Any question? Are you sure? No one is responding to questions. Okay, I guess there's no question. Everybody understood. Everybody understood this one perfectly now. So I guess congratulations, we are done with the aspect of arrays now. You can see what when I say each of these topics are broad. So we've done pointers, we've done arrays, and even mixed it with pointers to join. So I think the last one is strings, which we are going to look at next. So I hope tomorrow might be okay. I'm not really sure of how my schedule might be like. So just so we can end it once and for all. So we need to do that last part of strings. So if you are really following, if you followed for that pointers and you followed for these arrays, honestly, you are really doing well and you are really understanding this very well. Okay, so you can even look at most of those ALS questions and you get to be seeing read the meaning to it this time around since you can understand this concept, especially this particular last part of arrays and pointers. So this is like one of the ones that is really confused some people whenever they'll be seeing this additional stuff without really understanding what it means and how to point into each of them. All right, so I don't know if there's any final say or any final contribution before we all leave. Anyone with anything to say? Why didn't you use ampersand when giving the PTR int value? You mean the asterisk? Okay, no, you don't need to put that stuff there now. I think if you've learned pointers in my previous video, we've talked about that already. So whenever doing this stuff, like well, after you've declared your pointer like this, the next thing is just put the name of the pointer itself, then put the address which the pointer is holding. That is the value will be an address of something. The only time you use this pointer sign is when you want to modify something. Just like this part now, I when I want to modify all of this, I have to put this asterisk here, which made me be able to tap into something. But if I'm just as if I just put normal this stuff like this now, like this, like imagine, okay, exactly, okay, good example. Look at this print F here. I just put the PTR int. It's what it just prints for me now. It only prints here. I put percent %d, percent %p, which means it's just printing the address of my PTR int itself, its address itself. So that's just, it doesn't really pertain to something related to pointer. So when you're dealing with pointer, that's when you now put that the reference operator, which is this asterisk, just so you can really say you want to find out or fish out something inside whatever address that is being stored in this place. So this place have to be an address and the name have to just tally. So just like a pattern. If you watch my previous video, you get to understand this very well. So watch my previous video on pointers and you won't get issue with how why I wrote it this way. Okay. So is there any other question aside that, please? No, I mean, okay, this and stuff. It's just like what I said now. You can put that and stuff. Look at the option here. Like I said, naturally, when it comes to lists, when it comes to this, once you just write the name of the list, it will automatically take the address of the first element. So you can choose to write this way, or you can choose to write it this way. So you can see the ampersand sign is still here. Okay. And then this is the initial part here. So this is also still the same thing as that former one I wrote. So that's why I comment it just so you know that they're still the same thing. All right. Just that most times you may just not see it this way. You may just see it like this. But you'll not be wondering that pointer takes address. You'll not be wondering why is there no and sign here. Like you'll be wondering. So I'm just explaining it for you to know that it's not there because probably the person just wants to point the first one and nobody want to stress that step and be doing this one and then they put in this one since they know that just writing the name alone will take the first one already just to save time. You get just for simplicity. So that's just what it means there. So is there any other last says? Okay, I guess there's no other thing. So I think we are done for today. Thank you very much for your time. It's okay, go on. Okay. Yeah. Ah, you don't have it. Yeah. Uh-uh. Uh, and you've tried Google like to check the error or the error message or something like. Have you tried to? Yeah. Wow. Actually, you are not the first person that have complained this to me. I noticed that has been happening to some people's systems. Some it's working, some it's not working for them. I don't understand why, honestly. I don't know. Maybe Maybe I'll try to Google and check research about it, see if I can get to see a possible solution. So are you saying so far you've been using this particular interface to practice this programming, just that it involves internet? Wow. Oh, sorry about that. Whoever I'll help you to check then. I'll check the error message. If I can get to the solution, I'll paste it in the group chat. All right.
All right.
All right. I guess that's all for today. All right. You have a lovely